Hello, protocols, packets, programs, and replicants. You're an AppSec, walking along in the code, when all of a sudden you look down. It doesn't make any difference what AppSec, it's completely hypothetical. You look down and see a program. It's crawling towards you. You reach down and you flip the program over on its back. The program lays on its back, its belly baking in the hot sun, beating its legs, trying to turn itself over, but it can't. Not without your help. But you're not helping. Why is that? Which means this week we chat with Vandana Verma about open source security, building a security program, and bringing AppSec to developers. In the news segment, JSON and the Regex, IoT in the garage, CAN injection in the Toyota, Twitter and the CVE, complexity and security, and more. Have some empathy and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly.
Your organization is building and updating business-critical web applications faster than ever. And with so much pressure to move fast, you may find yourself making trade-offs between innovation and security. Now you can build fast without sacrificing security with Invicti, the zero-noise application security platform that helps your dev, sec, and ops teams work together to secure every website, web app, and API. With unparalleled accuracy, coverage, and automation, Invicti scales like no other AppSec solution. Invicti, AppSec with zero noise. Visit securityweekly.com/Invicti. Struggling to secure all your applications with modern identity services? You're not alone. But with identity orchestration, you can say goodbye to refactoring and complexity. Strata Identity helps you modernize app identity at scale while mitigating security risks and simplifying policy management. Maintain a consistent security posture and simplify policy management with identity orchestration. If you're ready to simplify your identity environment and improve your app security, share your IAM challenge with the Strata team to get a brand new set of earbuds. Just visit securityweekly.com/strata to learn more. That's securityweekly.com/strata. This is episode 236, recorded April 10th, 2023, which is also Leon Kowalski's incept date. Happy birthday, Leon. I got you a tortoise. I'm your host, Mike Shima. I'm here with John Kinsella, who I believe is more human than human. Hello, John.
Pretty sure I'm still a human, but it took this human a few seconds to get that reference, but still I appreciate it.
Yes, we're thanking all of our Blade Runner fans out there for picking up all the references, and I'll put a link in the show notes later for those who don't. The other thing you can do, speaking of visiting links, is join us at an upcoming official cybersecurity summit in a city near you. This series of one-day invitation-only executive-level conferences are designed to educate senior cyber professionals on the latest threat landscape. We're pleased to offer our listeners $100 off admission when you use code SECWEEK23 to register. Visit securityweekly.com/cybersecurity summit to learn more and register today. And Mr. Kinsella, we're doing something a little bit different. We're going to start off with the news. And we have a ton of news, and I think we have a couple themes that are going to emerge here. I don't have a good AP I don't know question to start us off, so listeners, please send us one. And send us many. In fact, we have a lot more of these episodes to go through. But John, we definitely saw some similar hardware car-related themes, but I did want to take us back in history a little bit to real quick 2008 write-up that was just published this past week about silently securing JSON.parse. And now this is a bit of history because JSON.parse used to be just pure JavaScript. It wasn't even part of the language. It wasn't a native function that you could call from the browser, from within the browser. And it relied on a regex to basically make sure when it's putting some JSON blobs through an eval, that eval was not a built-in library arbitrary command execution. What's really neat is that this highlighted a subtlety of control flow characters in Unicode and how that interplays with the pattern matching, and I thought it was really fun, a good bit of trivia of history. But there was also a neat thing at the end where the person who reported this sent an email to Douglas Crockford. And Crockford, as many people may know, is pretty familiar with JSON, having created it. And he, even in the response, was, "I'm not sure what's going on. Tell me a bit more." And so I wanted to highlight that aspect because it was the idea that developers aren't stupid. It's not like developers don't care about security. Developers just and AppSec folks need to have good communication skills to explain this is what's going on. Here's the subtlety of a control flow character that's actually backing us up so that the regex doesn't notice that you've actually skipped past a double quote or skip past a backslash. So that was a part that I really just wanted to highlight that for. So I don't know if you've been frantically updating all your regexes now, John, but
I don't spend too much time going back through my 2008 code.
That's probably good.
But it's actually, it's sort of, to put a slightly different spin on what you were just saying there, I talk about sometimes from a startup point of view, but even just like any open source project or anything we write, we create something with like our little sort of, this is what we're doing or this is why we're doing. And it's always really beautiful to me when that thing goes out into the wild and you see someone else, like a user or a company or a customer, what any of those things, like suddenly have this very excited about using your tool in a completely different way. And it's like, it's really this sort of magical moment of like, wow, I never would have thought of that. But at the same time, we have to remember that same type of thing can happen in security, right? And it's, there was another article I was going to put in, but I didn't, from HBR talking for managers about, thinking like a hacker. And it's that same type of thing. It's like, don't always be in your little guidelines. Like think about your guardrails. Think about what else could that thing be used for or used against. So yeah, it's interesting to see, but not unlikely.
Indeed. And we'll come back to some regular expressions and some history as well. But we've got a lot of hardware-related items this time. And I picked out one that was just about an IoT garage door opener that essentially they were putting the same password everywhere. And it's nothing new. I don't think this is going to surprise you. This is probably also the type of issue that goes back before 2008, for that matter. But what stood out about this scenario is that the researcher found this vulnerability in iDoor, hard-coded passwords, basically could open doors arbitrarily, but they couldn't get the company to respond, even to acknowledge that perhaps this is a problem. So this goes into that category, less of the IoT is just insecure because of so many common problems, but just how do you get coordinated disclosure, responsible disclosure, any type of disclosure when they've metaphorically closed their doors on you. So not a good look for the company next here.
Yeah, that's the way you're describing. It's funny, I don't know if you noticed, but I actually have a link in on this as well from a different angle. But you're giving me a bit of deja vu. I've dealt with this with like, I'll leave the details out, but like another vendor out there where like they blow you off, and it actually feels a little, it's disconcerting in a way, but it's depressing in a way. It is, it makes you lose faith, and it makes you just not want to keep doing some of that research. It's like, you're like, dude, I just pointed something out to you, it's so obvious to fix, and it's such a bad hole. It's like, what are you doing? And like, that vendor or whoever it is, they have other priorities, or they don't care, or maybe they don't understand, and you're not doing a good job explaining it. But it's unfortunate, but it happens. The other aspect of the story I had on it was one of the ways they're working on mitigating this right now is they've turned off the internet access. So if you want to control those garage doors from this vendor, you still have Bluetooth. And I thought that was sort of interesting. It's like, okay, well, I think in many cases, if we see a vulnerability in our product and it's pretty severe, we don't want some idiot on the internet just opening garage doors. Sure, kill it. But the thought came into my mind of two things for our listeners to think about. One is, how long would you leave that disabled? Like, is a day okay? Is a week okay? Is like a long weekend? Like, what's that period of time of we can shut it down for X days in a understandable way. First, before you have an actual fix. And then the second thought around that is, when you're writing software, how much thought do you put in ahead of time to, hey, there might be a vulnerability here. We might need to disable this, or we might need to do something. Do we do that with feature flags? Do we have an ability to, not shut down everything, but only shut down in a granular way? How much thought do you put into that ahead of time, right? Because fixing it after the fact is too late, because you're not fixing, right? This is sort of a security feature. But it's interesting to think about that. I think of like, how much thought do you put into that side of things to make your response be effective?
Yeah, it goes into that. These are non-technical security considerations, right? And there's no top 10 list for how to go through that decision-making plan. There is, however, a reason that you might keep your car parked in a garage and have that garage locked, because if you have your, I think would you have a Ferrari 308 GTS?
Yes,
John, parked on the street. That. Go check the headlights. And this was an article that caught both our attention, but I'd give you first crack.
Yeah, so this was an interesting story. And what I want to do on this is, while I organize my tabs, is sort of go in and talk through the actual story. I had some fun this weekend with not so much, there's still technical people, but not security people, and actually walking them through what was going on here. So I'll try and keep the storytelling brief for our listeners, but I know like even our producers were like, tell us more. So this security researcher in England came out some morning and found these pry marks on his car near the headlight, and like some of the plastic had been pulled away. He was like, damn vandals. Like, he could figure out it was a vandal because it wasn't it was on the sidewalk side, not on the car, on the driving side, right? It wasn't like it got hit by a car. And he sort of shrugged his shoulders, went to work, no big deal. Or big deal, but, what do? You deal with it, living in the modern world. And like a few weeks later, this happened again. And like, you could see someone's trying to get at his car. And it's like, it's okay, it's a pretty targeted thing, right? It's not just like whatever's going on. It's like, this is a security guy. So sort of it's poking at something in the back of the head. And then a few days later, again, the car gone. And at this point, it's like, now the picture's making more sense. So what's actually going on here? If you think about a modern car, and it's going to vary in the level of luxury, or, talking about the 308 probably doesn't have CAN bus. But the level of fanciness of your car and how many gadgets on it, all these type of things. But pretty much any modern car now has what's called a CAN bus in it. And I have to admit that I completely forget what CAN stands, but I'll figure out here while we're talking. So what happened is everything in this car is controlled on these buses. There's usually multiple buses in the car. And so what's going on, CAN stands for Controller Area Network. See, I can Google and talk at the same time. I'm improving my skills. But so there's multiple of these buses in the car. They're trying to do sort of like a staggered multi-tier type security thing to a degree, but there's no real security in here, right? It's a car. Who cares about security? So what's going on in this particular case is you've got multi-levels. And let's see, there's a diagram in here. See if I can talk. And this is a really good blog post. People should go and look at this in our notes. It's a really great write-up. But so in this particular one, he's showing 3 different CAN buses. So one's sort of, I'm going to talk this through to give people a sense of what's going on in a modern car. And like we've talked about Teslas in the past and 250 CPUs or something. But from a networking point of view, you got one network which is controlling engine control, your hybrid battery stuff, and your motor inverter if you've got like some sort of EV thing. You've got another CAN bus which is talking about radar, your parking assistance, forward cameras. So it's more about driving the car, and if you're backing it, making sure you don't hit somebody. And then the third one in this example has headlights, air conditioning, parking brake, door controls, telematics, so like sending stuff up to the cloud and saying, here, the car has errors or doesn't have errors. And the important one for this story, I mentioned headlights, and the second one is your smart key. So with a lot of cars nowadays, for folks who either don't drive or have like, a 57 Chevy or a 308, all our listeners with 308s, props. But so with the modern car, your key stays in your pocket. You walk up to the car. As you go to open the door, a few things go crunchy inside. Basically what happens is that first network sees the smart key. There's an RF transceiver. It sees the smart key. They do their handshake. It goes, that's legit for this car. He sends a message over to CAN bus to this sort of router gateway in the middle. Someone else say, hey, go ahead and unlock the door if that's what they're trying to do. Okay, cool. Person gets in the car. Next, you go to start the engine. There's immobilizers, all different type of things going on in there if you're not a Kia owner. And it then says, okay, we've got the smart key in the car. We've got the doors unlocked, the alarm's undone. Let's go ahead and start the sequence for starting the engine. Okay. So we're talking about headlights. Why in God's name would you connect a headlights to a network? So in a modern car, again, and you might notice in some cars when you turn them on, it's the best time to see it. The headlights will, if you're in a dark garage or at nighttime, you'll see the headlights in some cars start to go up and down and then move side to side. And where this came from is someone came up with the idea that when you're turning on a dark road at nighttime, if you can have the headlights sort of bend and, sort of go where you're going, or sometimes they'll have their high beams are actually now controlled instead of like a relay or a separate light. It'll just, the CAN bus will tell the headlight to move up and down. And for those of you who've been in accidents, now you're starting to get a sense for why a modern headlight in a car can cost from like $500 to $1,000 to replace. They've become these fairly expensive things. But anyway, so back to our security point here, what's going on? Some obviously fairly intelligent folks figured out that, hey, how could we get into a car if we don't have the key or whatever else? So if we pop out the headlight and we are able to take that wire going into the back of the headlight and get on the CAN bus, we might be able to inject stuff in there. And that's what they figured out, and that's what they've done. So the blog post goes over this in fairly fun detail. And some of the stuff you're seeing in there now is, so they want to, they're trying to pry enough the car out to get the headlamp out. Most cars nowadays, that headlamp isn't actually, it's not glued or screwed in. It's usually just sort of sitting there. So that's why if you get like an fender bender, like lights start popping out everywhere, right? Modern car things are sort of clicked into place with plastic things. But so, they pop the headlight out, and they plug in this little special device which they have, which they've designed to look like a Bluetooth speaker. So if a cop sort of stops you, you're like, oh, I'm just listening to music. It doesn't look like it's something. But they have this in there, and then post goes through. And Mike, if you want to talk about some of the details, it actually manages to, block out other traffic on the network, send their packets through to actually say, hey, the car is unlocking, and the fun continues from their point of view.
That's a great overview. Thank you for that. And what's amazing to me is what you've described is, if we took away the words controller area network and stop talking about headlights and cars, we're basically talking about a TCP/IP network, or UDP, in the sense of, here is a security boundary that we've gotten past, meaning we've gotten to the headlight, we've attached to this wire, and now we're just saying, oh, rather than the key, rather than your smart key, as you said, saying, I've unlocked, disable the immobilizer, the headlight is just sending a message that says, hey, yep, key is validated, unlock the immobilizer. And that's something, that type of spoofing fake messages probably shouldn't be coming from your headlight, but that's what that's what this comes down to. So this is why, car manufacturers should have been studying TCP/IP networking as early as the 80s and 90s, and understand how all the good, basically they've reinvented BGP, I suppose, for cars.
Oh, God. You keep bringing up things I'm studying. I like BGP, unlike IPsec. We'll talk about that later. So yeah, they have a few good mitigations in this article. I mean, the guy who wrote this article is apparently one of the sort of experts in the space of CAN networks. He helped Volvo build their network in some of their cars. So dude knows this stuff really backwards, inside out. There's like screenshots in there of like logic analyzers actually showing how this stuff works and stuff. It's a pretty cool article. One of the ways they talk about mitigating this is actually to encrypt the traffic and have like a, some sort of a symmetric encryption, which means you're going to have a key programmed into that car at the manufacturer. And then if you start replacing parts on the car at your local dealership, they're going to have to start being able to reprogram things. Okay, so do you actually do key management right, and you have a separate key on each car, or do you have like one shared key? And, longtime listeners know what's going to happen here. So some automobile manufacturer next few years is going to have a standard key, which we'll go find out. But yeah, I think of it as I would say digital network, not even like a TCP network. But it's interesting. It's these things have been used in there, and it seemed like a great idea. And here we're back to standard. We'll have Vandana back to talk about car networks in a few more years.
Well, we'll have to. And yeah, so people taking their cars for smog checks, they'll have to start taking them for Let's Encrypt checks to update their certificates. We'll see. But this wasn't the only type of hardware that was catching your attention this week, John. There are also a couple things without wheels, like printers, that also have, rather than expensive headlights, they have expensive ink cartridges and whatnot. But they also have flaws. Tell us about some of the flaws that caught your attention that look pretty fun to you.
Also, this made my head explode a little bit. So last week I was talking about IPsec. I'm not a huge fan. I mean, I know how to use it. It's got its uses. And to start to clarify that a little bit, it's not like I'm like, oh my God, IPsec horrible. If you've had to configure IPsec on like large scale enterprise routers like Cisco's and Juniper's and things like that, which I did for a few years with a third party, the problem comes into there's so many variations in those protocols that getting two groups which have never works together or talk together to get that IPsec tunnel working across different vendors, that's where when I start talking about why I don't like IPsec, to be clear there. Protocol itself is great. But speaking of IPsec, so yeah, HP Enterprise printers, which happen to have scanners on them. I'm going to see if I can turn this around because the article wasn't really clear to me at first. Some of these enterprise devices out there have the ability to scan to either SharePoint, sorry, I should have said trigger warning, but SharePoint or to email. Okay, that I can sort of see value there. It turns out that some HP LaserJets have the ability to be configured to do IPsec connections. I don't know why. So I put this in the show notes, and please, any of our listeners, if you guys have done IPsec on a printer, please reach out to me. I'm really curious about why you do this. This is just like sort of blows my poor little mind. But yeah, so IPsec on a printer. Whoops, sorry. And in that particular use case, for whatever reason, for a version of the firmware, which was only out for a very small period of time, apparently, you'd get plain text disclosures of potentially credentials or other things across that connection. So it sort of bends the brain in a few different directions. So A, you can put IPsec onto a printer. B, once you improve the security, you're now sending communications in plain text. Yeah, so that's the use case here. And sort of to hit the story up front, well, I do talk a lot about hardware. Part of the reason I do is I'm always looking for different sort of things that have a sort of a physical aspect which we can bring back to people and talk about. Like, hey, this little thing in my hand. For people who've done Zooms with me when I'm at home, I've usually got some sort of device around, like I can actually show things and sort of poke and tweak. And I like that aspect of being able to communicate security in a more physical way. So that's frequently when I talk about these things. But yeah, here's another one for you.
Indeed. And other tangible things is that most people have printed something at one time or another, but I think today everybody has a Wi-Fi network, whether it's at home, coffee shop, or business. And I had alluded to, touched on some papers from real world crypto about some Wi-Fi attacks. And so listeners, go check out show notes from episode 235 last week. But this week we've got another one that's pretty neat because it's mucking about with ICMP and can even hit WPA3. And that's the part that stood out to me because one of the tenets, one of the properties of WPA3 is that it was much better about encrypting all of the packets, including the management packets, and that WPA2 had, I'll say, forgotten about or neglected to encrypt, meaning that that would enable some intermediation attacks. So that's my setup for this. Take it and run. There's no IPsec in here, John. So hopefully this won't further beat down your poor brain.
Praise be my poor brain. And I'm going to throw this one back to you in a second on the web because WPA. I didn't fully understand what was going on there. But yeah, we've had a few Wi-Fi stories here in the last few weeks. And then this is again, so it's not so much a deauth, but it's a man in the middle. What's going on here is these researchers from a few different locations have figured out that they're able to send an ICMP redirect packet they can spoof that and send it to the client and say, hey, I need you to send that traffic that you've got going on over here to, this is where you really should be. And then at that point, they've got the traffic, and then how they're encrypting is what I missed in here. But the reason this is an issue is, well, you shouldn't be able to do that. The routers that we're communicating through, and the access points, but particularly the routers, should be inspecting this traffic close enough that they go, that ain't legit shit. I'm supposed to be sending redirect packets, not you, dude, or dudette, or anyways. But that's going on. And apparently what's happening is the amount of computes to actually inspect the packets at a level 2, figure out if it's spoofed or legit redirect packets. So around 90% of routers are not doing this, Wi-Fi routers. It's interesting in the write-up, they went through, both on the router side, a good collection, I want to say around 100 devices. And then they went out and started, it looked like they were testing the wild, which sort of raised my hairs because I'm not a big fan of that. They mentioned restaurant 123, campus 123, fast food, restaurant, coffee shop. You get the idea, bookstores. So it sounds like they were doing a little bit of real world testing here, which is, I'm always a little sort of cautious about personally. I don't like recommending that. But yeah, so it's sort of walk through. So this isn't just a walk in the park. You have to know on the client device, you have to be on the same network. you have to find I believe it's a UDP port which is open and there's traffic going on it. Then you have to be able to send the ICMP related to that little thing. And that sort of gets you set up to then have these packets coming at you that have WPA on them. So hot tag, you're it. Tell us about that, Mike.
Yeah, it's not going to be too in depth, but I think one of the key aspects here is that indeed you need a UDP port open that you can get that destination unreachable message back from that's a type of ICMP packet. And in this case, what it looks like is that because it's ICMP, UDP, these are predictable packet fields that you can craft. And so since you can craft these, the AP, for some reason, which I admit I'm not clear on, it accepts this packet in as plain text and it says, okay, this is at the link layer that I'm looking at this, rather than looking at the encrypted payload or the encrypted packet contents, that I'm going to respond to this the IP fields for this UDP packet, for this ICMP packet, and then attacker wins. And that's going to be my summary of this article. So maybe, unless you have something to add, we should move on before I get more or less technical.
That's it. I didn't mean to throw you under the crypto bus. Yeah, so these guys have, and so part of the reason we're going on, well, they've got a pretty good blog post on this. There's the actual PDF paper is coming out at a conference the next week or two. Maybe that's why we're seeing all these, was it Black Hat Asia? Maybe it was. Maybe that's why we're seeing the ramp up for that. Maybe there's like Wi-Fi field or something there, a Wi-Fi track. But anyways, yeah, that's all I got. Who do we want to pick on?
Let's talk about some vulns, and let's talk about some vulns that maybe aren't vulns. So we talked last week about the Twitter recommendation algorithm going open source, and I won't say it was a yawn. It was interesting. It does. If you go back, look at the show notes. There's a nice description of it. Part of the design of the Twitter recommendation algorithm is that it has a heavy ranker, which to me sounds like the name of a good '80s hair metal band. But this attack is, somebody looked at the algorithm and said, look, we can do some coordinated mass activity behavior and get somebody not banned, but essentially shadow banned. Basically, we can misuse, abuse. I'm trying not to say exploit, because I have a quibble with that language here. But we're going to abuse the algorithm or manipulate the algorithm so that this user's basically gets dropped to the bottom of the ranking for the recommendation algorithm. And so I linked to it's a nice write-up. It's a good description of basically what happens or what could happen, but it also has a CVE associated with it. And to me, I was kind of like, I'm not sure this is CVE worthy, or why would we have a CVE? Because this is kind of abusing a ranking algorithm, abusing an algorithm that is not unique to Twitter. In fact, it's you can see this type of gaming the system on Reddit, Facebook, many other types of scenarios.
Yeah, I'm with you. I wouldn't have put a CV on that either. 2023, 29218 for those playing along at home. It doesn't look like it has much details on it all. So I don't know. It'd be interesting to see whose block that came from. Like, how did they get a CVE for this? But anyways, I guess, this in a way to me is sort of one of the hopeful things I looked up to machine learning to sort of help us with. Sorry, rainbow hands. From the point of view of all these, and I think this happens across so many different platforms. It's not just Twitter, but it's we know that we want to do some type of blocking around if a bunch of, you want to do some sort of, I'll say downvoting, as you said, shadow banning around if someone is being a bad individual. It's hard to do that at scale and have people on Twitter side to handle that, especially when they're all being fired. But so you want a machine to sort of figure out, okay, if we see a collection of folks out there that think this ain't so great, maybe we should start to sort of tamp it down a little bit. But at the same time, there's the yeah, but, right? So how do you do that in a artificially intelligent way? How about if I say that? But right, you have to get more and more complex. And there's I had just highlighted a quote or a law in one of your other stories, which I think we're going to come back to and reference this. But yeah, these things, they start off, they sound really simple, right? Just that whole concept of that I'll talk about of like things which sound easy are actually fairly hard to do frequently, and things which sound pretty hard are often in software development fairly easy. And I think this is one of them. So it's interesting to see that they put it in there. It's really interesting to see someone gave it a CVE, but I mean, yeah, I'm with you on that. It's not really an exploit in my mind.
No, and there's a vulnerability in VM2, so everyone go run out there and do your npm audit fix, update that. I highlight it because the exploit code, the proof of concept was something like a dozen lines of very simple code. So it's fun to look at. Nothing too much more exciting to talk about there. John, you've also found one, a JDBC vulnerability. You wanted to mention that real quick?
Sort of same thing. And the reason I put it in here, I'm trying to give the listeners occasionally chances to see how does it look, what does a fix look like, right? So I saw this last week and I'm like, oh, it's Apache, so I'll be able to get the pull requests and stuff. So that's what I've dropped into the show notes. And it starts with, this is the pull. So you can actually go and click on files changed and see, what actually, how do you, so the actual problem here to talk through very briefly, Apache Airflow is a package which is used for doing workflow management. Hopefully no one's hearing the snowfall off my roof, but hopefully it's a workflow management tool. They've got a module that works with Spark, which has a JDBC hook in there for reasons. I think you get the idea. It's big data and how do you move data around, that type of thing. But so there was a vulnerability where with that Spark module, you could access any file-to-file system through the JDBC URL. So the issue going on is, the JDBC URL, if it had like a / in the connection host or a question mark in the schema, that's a way that they were able to sneak a request in there for a file. So very simple, 4-line fix. But what's nice about this is then they go and actually modify their test to be able to, they're doing sort of test-driven development in a way. But it's nice to sort of see then they're pretty simple pull requests for folks who want to see what this looks like in Python. And yeah, we can keep going.
And I think it just points out that they could have used a regex to catch those / and question marks. But once you start using regexes, they become complex, much like other complexity of content moderation or handling large social networks. And this brings us to another article from Phil Venables. We've covered a few in the past. And actually, we covered another one that did also talk about complexity and security, and that these are forces not necessarily in opposition, but are in friction with each other. I think that's kind of the subtext or the actual text of this article that we pulled out. It's another long one, very well worth reading, especially for any AppSoc folk, any developer out there, just to understand what are good ways to handle complexity. Embrace complexity and engineer your way through it, or engineer it in a way that it becomes useful. Real quick, I wanted just to highlight, it talks about opinionated defaults. And this one is an area which I would love to see more of, in the sense of no more 20-page PDF hardening checklists. Opinionated defaults come out, and it's more of you turn it on and it's default secure and usable. I think that's important, because there's also another bullet point here is it still needs a great user experience. But it's describing how it's the user experience should be intuitive, provide feedback about what was the intent of what the actor did, and did that follow through? And then real quick, we've talked about transparency and breaches. This talks about the 5 whys and blame-free post-mortem. So another just good aspect of building a security culture. So those are the things I want to hit real quick. But this one, I think, spoke to you as well.
Yeah, I think this one was, at least, I don't want to say it's one of his better ones. I want to say it really resonated with me for whatever reason, where I'm sitting or what's going on. There's a lot of sort of really succinct, good points about this, which I think is something we don't really think about. So first I want to hit that law, which I was just talking about, or foreshadowing. Tesler's law, he mentions, which is also known as the law of conservation of complexity, states that for any system, there is a certain level of complexity that cannot be reduced. According to the law, each application has a certain degree that either the developer or the user has to deal with of complexity. And I think that's what's sort of interesting around this is, especially in a larger org, like, I mean, he's at Google, can you imagine, where you've got, he has a diagram and they're talking about like the different sort of business layers, financial, operational, and external. And that really comes down to all sort of points he's talking about, which I think we frequently don't give. I mean, I think we know inherently when we're in those roles of like, you've got all these sort of different directions coming at you. But from, I mean, hell, think about this from a threat modeling point of view also, of like, I keep hitting this mic today, sorry. But think about, not just like, hey, there's an attacker coming at you, but like that tabletop has to start getting pretty big to do that tabletop exercise. Like I think you've got a story in here for RSA. And and again, it's sort of back similar to the Twitter example of it seems simple at first to do that threat model, and maybe in your less mature models, or your less mature implementations or executions, it's just like attacker bad coming at me, SQL injection, how fix. And then as you start thinking about that, either in a bigger company or as you've done it a few times and become more mature about how you think about it, it's like, okay, well, there's Judy in finance, there's this guy over in marketing who's sort of frustrated. There's the attacker with the SQLi bad, and like there's all these sort of different types of things. So there's a lot more juggling going on to fix, and I think that's really interesting to think about and keep in mind.
Yeah, and I'll pull in that article that you mentioned, the threat modeling, because you highlighted the key aspects of it to me that makes threat modeling successful is discovering where that complexity is either unowned or unfamiliar or who to talk to. So those tabletop exercises aren't about the coolest way that they pulled off the SQL injection. Okay, fine, attacker did that. Let's worry less about that and worry more about, oh, wait, does legal have a run book? Do we have to, who do we talk to in privacy? Does this touch on finance for some reason? Or, who do we talk to? I think is kind of is what a lot of those good tabletop exercises can highlight, lines of communication, as well as just making sure your run book actually covers a couple edge cases, a couple strange things that might come up through the creative thinking, not of the specific type of exploit, but of the consequences, what happens post-exploit. So yeah, I think it's a good companion to that's definitely that article was definitely much lighter compared to Phil's and talking about complexity. And we've got to save some time to go talk to Vandana, John. So there's a couple articles. There's a flaws.cloud walkthrough that's a walkthrough, no spoilers. So just go read that if you want to go play with flaws.cloud or just understand how to do it. But I also wanted to note the anniversary of Heartbleed. This was something that ruined the weekend of many DevOps and AppSec teams back in April 7th, 2014, when when that CVE, which was quite deservedly assigned, came out. And I have my comments in the show notes. Go visit there. I'm not sure if John, anyone wants to. You want to take us out on this particular segment?
Oh, no. Yeah. I mean, it's so many years ago, and we're still talking about it. Like, it just gives you a sense of like some of these things which are so core to us wherever we were then, or if we knew about AppSec or not. They still sort of come back and have you thinking about it. So I think it's good to sort of maybe go back and revisit that, think about it briefly, and get ready for our interview with Vandana.
Indeed. Let's get ready for the interview. Thank you, John. Thank you, listeners. We're going to take a quick break and return with our interview with Vandana.